Experiment 5.1 Protein precipitation with reagents. In this experiment, we will study protein precipitation of protein in egg white by use several reagents and investigate the effects of each reagent. First step, separate the egg white from egg yolk. Pipette 1 ml of egg white into the prepared test tubes for sample group. And then pipette 1 ml of distilled water into the prepared test tube for control group. Second step, add 10 drops of reagents in each tube, including the sample group and the control group. The reagents that used in this experiment are lutein, gallic acid, tannic acid, TCA, acetic acid, ethanol, acetone, lactic acid, PG. Shake the tube gently and wait for 5 minutes. The final step, observe the precipitants and note as +1, +2, +3, and +4 to evaluate the degree of precipitants. The result indicated that each reagent have different precipitation efficiency. We could classify the reagents as 4 groups by the strength of precipitation efficiency. The +1 group contains gallic acid and PEG. The +2 group contains lutein and tannic acid. The +3 group contains acetic acid, ethanol, acetone, and lactic acid. The +4 group contains TCA. We can conclude that protein can be precipitated by many reagents. Each of reagents have different mechanisms to precipitate protein. So, the best reagents depend on the objectives of works. It depends on what the precipitate protein is going to use for. Experiment 5.2 The effects of pH on protein function. Catalase is a common enzyme that can be found in many plants. This experiment is studying the efficiency of catalase activities of Chinese cabbage and cabbage extracts at different pH conditions. The first step, weigh 0.1 grams of each pan and put into the mortar. Then, add 3 ml of the buffer with pH 3, 7, and 11 into the mortar and gently clean until the plant extracts are homogeneously mixed. The second step, put 1 ml of plant extracts into test tubes and record its initial height. The third step, add 1 ml of hydrogen peroxide into the reaction and incubate at room temperature for 1 minute. After 1 minute, The air bubbles will appear in each reaction tube. Record the final height of the air bubbles in each tube. From the record result, plot a graph that shows the relation between rate of enzyme activities and pH. This table shows the effects of varying pH on catalase activity. The catalase extract from Chinese cabbage show the highest activity at buffer pH 7 followed by pH 11 and pH 3 is the lowest. The catalase extract from cabbage show the highest activity at buffer pH 7, pH 11 and pH 3 respectively. Conclusion from this experiment is enzyme catalase have the highest activity at pH 7. The enzymes have good activity in the pH range 4 to 10. So, catalase may lose its activity in pH lower than 4 and higher than 10. pH change affect the charge and the active site of the enzyme as protein molecule.
Experiment 5.3. The effect of temperature on amylase enzyme activity. This experiment proposed to evaluate the amylase activity for skunk white root on different temperature. Iodine solution is used as an indicator for amylase activity by interact with axis starch. First, the gelatinized starch is prepared by add 0.04 gram of starch into 50 ml beaker. Then, add 20 ml of distilled water and stir gently before bring it to boil on hot plate at 100 degrees Celsius for 3 minutes. During this step, stir slowly until the solution is clear. Then, the gelatinized starch solution is cooled to room temperature. This experiment used 9 test tubes and divided into 3 groups. For incubate at 4 degrees Celsius, 37 degrees Celsius, and 100 degrees Celsius. Each group contains positive control tube, negative control tube, and sample tube. Add 1 ml of gelatinized starch solution to all tubes. Then, add 1 ml of amylase from saliva into positive control tube. Add 1 ml of distilled water to negative control tube. And add 1 ml of amylase crude extract from skunk white to sample tube. Incubate these tubes at 4 degrees Celsius, 37 degrees Celsius, and 100 degrees Celsius for 20 minutes. Add 1 drop of iodine solution to each tube and gentle mix. Observe the color change and record the result. After iodine solution was added into each tube, it appeared different shades of blue color. At 4 degrees Celsius, it appears dark blue color. It indicates that amylase won't working. At 37 degrees Celsius, it appears light blue color. It indicates that the amylase has nitrolateral activity. At 100 degrees Celsius, it appears blue color. It indicates that amylase has low rate of activity. The results show that the amylase group extract from scum wine root has a highest rate at the activity at 37 degrees Celsius, followed by 100 degrees Celsius and 4 degrees Celsius respectively. Starch contains alpha amylase, a helical cyclic polymer, and amylopectin. The structure of the helical amylose is key to the iodine starch reaction. Starch forms dark blue color complex with iodine. Simple oligosaccharide and monosaccharide don't form this complex. Therefore, color intensity indicates enzyme activity of amylase and concentration of starch in the sample. Experiment 5.4. Effect of enzyme bromelain to gelation. Bromelain, which is present in large quantity in the fruit, leaves, and stem of pineapple, is a proteolytic enzyme or protease that catalyzes the breakdown of protein into amino acids. First step, measure 50 grams of pineapple into warm water and gently grind until pineapple juice is released. Then, the pineapple juice is filtered with a white coat into a beaker. It is called crude bromelain. Add 2 ml of crude bromelain into 2 test tubes. Tube H is tube for the hot juice. Second, tube F is the tube for fresh juice. Bring the tube H boil at 100 degrees Celsius for 10 minutes. When waiting for the heating of the juice, measure 2 grams of gelatin powder into the flask and add 10 ml of the distilled water into the gelatin powder. And dissolve the gelatin by boiling at the hot plate for 5 minutes or until the gelatin completely dissolved. Please be careful, the gelatin solution should be in warm condition to avoid foam in solidification. Next step, prepare 2 ml of distilled water to a new tube at a negative control. Add 2 ml of gelatin solution into 3 tubes. First tube contains fresh juice, second tube contains hot juice, and the last tube contains distilled water as negative control. Then, mix all the solution in the tube gently and place on ice box for 5 minutes. After 5 minutes, the tubes are removed. Tilt slightly and note the consistency of the gelatin in each tube. After that, take 0.5 grams of product reaction into a new test tube. Add 5 ml of distilled water in each test tube. Mix steadily. After that, add 10 drops of 8% weight by volume nitric reagents and mix again. Bring the solution heat at water bath for 5 minutes and record the intense purple color that formed from the reaction. The results of this experiment are shown as follows. The results show that the phase 3 solution that contains active formalin enzyme can prevent deletion in short-chain peptide. The prevent peptide lead inhibiting to bind a lot of amine and produce the intense purple color in the solution. While the formalin enzyme in hot juice was in active form, then it cannot break down long chain of deletion, leading to inhibiting less bind with amine of deletion. The solution not turned to purple color in a similar way to negative control.